Today we're going to learn about the naming of our unsaturated hydrocarbons, the alkenes and alkynes. Now, as you know, these are hydrocarbons that contain a carbon-to-carbon double or triple bond, and thus they are not saturated with as many single bonds as possible. This changes their molecular geometry, their overall shape, their properties, and their chemical behavior. So it's really no wonder that it's going to change their nomenclature some too. Now we're going to start with the basics. Overall, the general principle is similar to the naming rules that we learned with alkanes. We are going to identify how many carbons are in the longest carbon chain with our organic root, such as eth, prop, bute, etc. We're going to include an ending or suffix that identifies what organic family the molecule belongs to, and then name and locate any substituents off that chain in the same manner as before, which could include prefixes such as di, tri, etc. So our key difference so far is going to be in that family suffix. So far we've only used ane for our linear, branched, and cyclic saturated hydrocarbons. But now we're going to introduce two new ones. Ene for when there is a carbon-to-carbon double bond, and yne, Y-N-E, for when there is a carbon-to-carbon triple bond in that carbon chain. So in looking at our simplest unsaturated hydrocarbons, those that only have two carbons in the chain, we can see there's a similarity between this name, the name of our saturated one, and our unsaturated. We have ethane for the saturated, and then ethene and ethyne. Note also the change in their chemical formulas as hydrogens are lost to make room for these multiple bonds. And we see the exact same pattern on those with three carbons: propane, propene, and propyne. Prop indicating three carbons, and then the family suffix telling us the bonding pattern of those carbons and thus the organic family. So let's look at one with a substituent. As always, consider pausing the video to name it. Now, this thing we're looking at here is a structure that's sort of mixing both a skeletal or line formula with a condensed, and it's really common when representing organic compounds to kind of get all of those formula types kind of mixed in together. So right away, I see a double bond, which tells me I will be ending the name with ene. There are also three carbons in the longest carbon chain that includes the double bond right here, 1, 2, 3, which tells me that just like these ones over here, I'm going to be using that organic root prop, so propene. Now I do see a chlorine here, a chlorine atom off that second carbon, so counting 1, 2. Now, I do still get the number 2 if I count from this end, but I actually wouldn't want to do that because you always want to count in a way that gives the lowest number sequence to the carbons of the multiple bonds and includes both carbons. So the final name in my structure is 2-chloropropene. 2 to tell me that there's a chlorine off the second carbon, prop to tell me there's a total of 3 carbons in the longest chain, and then ene telling me that there is a double bond there in that carbon. Now, we do have a naming convention that is different than alkanes. Now, I call it the interrupting locant. Now, that's not its real name, that's just something I made up, but that's what I'm going to call it. Now, we didn't need to worry about the location of the multiple bond on those simpler structures because there was really only one option. But take a look at this compound. Is that the only way the double bond could be placed? No, it's not, is it? It could have also been placed between these two carbons instead, and that makes it something different. Now, so far, we would have called this butene, but these are not the same molecule. They do have the same number of carbons and the number of hydrogens, so they have the same molecular formula. But their bonding pattern, what is bonded to what and in what order, is different, and so they're not the same substance. Now, the location of the double bond does matter in order to distinguish between these structural, also known as constitutional isomers. In order to address this, we must tweak our naming format. We're going to interrupt the name between the organic root and the family suffix. We're going to add something right here with the location of the first carbon of the multiple bond. Thus, the name of these two organic compounds will be as shown: but2-ene and but1-ene, helping us distinguish between these two. Now, I think it's really important to note that the practice of placing the locant of the multiple bond here in the middle of the name is a relatively recent IUPAC change. And so it's very likely, very, very likely that you will run across a slightly older but still very common version in which the locant is placed in front. So 2-butene and 1-butene. Now, there are many online resources and examples that still use this system, and so it's important that you are aware. So last quick reminders: make sure when you're numbering your carbons that you number to give the carbons of the multiple bond the lowest number, and that you ensure numbering includes both of those carbons. So let's do a practice one that will help us kind of put this into practice. So here I see a skeletal formula of a hydrocarbon with a double bond. So I know we're dealing with an alkene. Now, I don't know about you, but when I look at this, I am so tempted to number it like this. However, you can see that this numbering does not include both carbons of the double bond, and so is incorrect. You want to identify the longest carbon chain that includes both carbons of the multiple bond and then number in the direction that gives them the lowest numbers possible. So instead, we're going to start over here because that will do both. It will both go through both carbons and give them the lowest numbers, and it's going to look like this when we number it. Now we're going to build its name based on our naming steps. So I can see that I have 6 carbons, so that root would be hex, and then I have a double bond, so the family suffix will be ene, and we are going to interrupt that name hexene with the location of that first carbon of the double bond, which happens to be on carbon 1. So far this would give us the name hex1-ene. Notice the location of our dashes. Dashes are used to separate numbers and letters. Now, we also have 2 substituents, each a 1-carbon alkyl group. So we're going to put that all together, identifying that I have 2 of the 1-carbon alkyl groups and their locations to get the name 2,4-dimethylhex1-ene. I'd encourage you to take a look at going back between the name and that structure. That is something that you're going to want to be able to do. Go from a structure to a name, or when provided a name, develop a structure, whether that's a skeletal, a condensed formula, etc. Now, I'd encourage you to continue practicing with your textbook or online resources. In our next video, we're going to explore naming alkenes and alkynes when they're part of a cyclic structure or when there's more than one multiple bond in the same compound.